One of the most common misconceptions is where modern earthquake forecasting techniques come from, specifically the science around deep earthquake energy transmigration. The following is from the breaking update posted on the homepage of QuakeWatch.net. Foreknowledge of earthquakes dates back to the very first recognition of an aftershock that was caused by a preceding large earthquake nearby. Since then, foreshocks and other phenomena like earthquake lights, ground ion emission, and changes in total electron content in the atmosphere have been recognized as legitimate precursor events to some large earthquakes. But efforts to determine which earthquakes and other signals will lead to larger ones soon afterwards have fallen short, and active earthquake forecasting remains largely outside of the mainstream lexicon of geophysics. One of the models to demonstrate success in correctly identifying foreshocks and pre-volcanic eruption signals describes how deep earthquakes in the mantle can influence the crust through a process known as seismic energy transmigration. Other studies have identified similar patterns in foreshock behavior prior to large seismic events, or have recognized other patterns in how some earthquakes trigger subsequent events. In addition to the subterranean pre-seismic signals, recent studies have identified numerous atmospheric, ionospheric, magnetospheric, and geospace signals that have preceded large earthquakes. Anomalies in charged particle counts, field characteristics, and radio signals associated with L shells have been detected before earthquakes, along with other fluctuations of Earth's magnetic field. There is a growing body of work on the electromagnetic precursors to earthquakes and on electric coupling between the ground, atmosphere, and ionosphere. Studies of crustal resistivity can give clues to the structure of the fault, and many fault zones contain low resistivity crustal contents. Models of the Earth's crust as a capacitor allow fluctuations of the planetary global electric circuit and magnetic system to complement known mechanisms for the production of electric currents and other electromagnetic signals before and during earthquakes, specifically via space weather modulation of geomagnetism, ground currents, and various aspects of the global electric circuit. Many of these works, including those previously mentioned on subterranean signals, have been combined to develop the model of forecasting magnitude 6 or larger seismicity. The various models and methods were analyzed in the time since their publication, and some of the most robust factors for forecasting magnitude 6 or larger seismic events were selected for real-world testing. These factors, compared against regional earthquake history, include the location of atmospheric pressure systems, 36-hour rainfall, weekly outgoing long-wave radiation anomalies, heliographic longitude of solar coronal holes, and deep earthquakes at depths identified by BLOT, which echo the introduction of solar energy into the global electric circuit and the geomagnetic system. We have termed these deep earthquakes BLOT echoes.